बहुत ही गर्मी है। Hello boys, are we back? Are we live? Hello boys, are we back? Are we live? ऑडियो चेक कर लेते हैं भाई। हेलो हेलो। ओके, अभी नहीं जुड़ेंगे। हेलो हेलो। क्या दिक्कत है? नहीं है मेरा आवाज़, तो आप लोग को माइक्रोफोन का बढ़ाना ही पड़ेगा। हेलो हेलो हेलो, 1 2 3। लीडकोड प्रॉब्लम चल रहा है। Hello. Hello, hello, hello. Hi. हम्म हम्म। आपको मेरी आवाज़ सही आ रही है? ठीक है। एयरफोन लगाना ज़्यादा बेटर है। ठीक है, ऐसे ही घूमना चाहिए। पहली प्रॉब्लम चालू करते हैं। कोई आता है तो पता लग जाएगा। फोन रखते हैं। Okay, so you're given a positive integer and indicating that okay, square matrix है, zero index. Okay, matrix filled with zeros. You're given a 2D integer query, row, column, top, row, row I, column I, row 2, column 2. Okay. Add 1 to every element in the submatrix from top left to bottom right column. So 2 column 2 and that is add 1 to the comma 1 within the matrix after performing the query. ठीक है 1 comma 1 1 comma 1 2 comma 2 फिर 0 comma 0 and 1 comma 1. Okay, we updated the values to zone. After every query we are updating every cell in that um, subrectangle or submatrix formed by these coordinates of the query. Again, the constraint for n is 500, 500 for 500 for matrix. In the worst case, 10 to the power 4 into m 10 to the power 4 queries. Okay. And um, these are the ranges where the coordinate of the submatrix will lie. If we brute force it 10 to the power 4 into n square, that is 10 to the power 4 plus 10 to the power 6, but still isn't within the range. Okay, we can update it with a difference array. Okay, let's try the example one. Uh, Close. Ah, another broke. Um, okay, we have 3 comma 3 matrix of length, right? Okay, we have 3 rows, 3 columns. Square and code. And so message. Mm-hmm. We have all series first. Now we have query 1 to update 1 comma 1 to 2 comma 2. So 0, 1, 2, 3, 0, 1, 2, and 1 comma 1 is here. You start with query 1, q1, and 2 comma 2. We need to update every cell in this query. So it will be changed to 1. Every element will be updated to 1. 1, 1, 1, 1, 1, 1, 1. Okay, so still fine. And the query 2, we have 0, comma 2, 1 comma 1. So the submatrix will be from 0 comma 0 here q2 and 1 comma 1 is q2. So every cell will be this 0 will be updated to 1, this 0 will be updated to 1, will update to 1, and this one will be updated to 2. So and then we will have like this. We have 1 1, we have 1, we have 1 1. The final after updations we have 1 1 1 0 0 1 2 1 1 0 1 1 1 1. Okay, this is the correct matrix here. Yes, 1 2 3. Oh, why do you have 4? 1 2 3 4. Why we have 4? So sorry, this row is not valid. Need to add. Okay, sorry. From the we did an epic wrong. Yes. 1 1 1 1 2 1 1 0. Okay, we have this the correct matrix. But brute force, thinking brute force, every query we are going to we are going to form the matrix from way to way we have to uh, we are going to form the matrix submatrix for the query and update every element to 1. Now add every element in that rectangle to 1 and increase the every cell value to 1. So for query will have max we can have, and we will at max we can iterate about n square, right? N square cells in brute force per query. For all queries, q queries, we are going to traverse n square. So 10 to the power 6 and 25 into 10 to the power 4, 10 to the power 4, 10 to the power 4, right? 10 to the power 4, 10 to the power 2, 10 to the power 4, 10 to the power 10. So it's going to TLE. Brute force won't work here. Okay. Now I think we have okay. If this was an okay, if this was an one-dimensional matrix, right? Single rows and multiple columns. So we can use difference array where For the query, we are given the index uh, uh, from where the from where we are going to start and where we are going to end. J I and J will be given ing for the query. UI for UI I comma J. Right. So for every cell, we're going to update if this cell is I and this is J. Difference tell us to add a 1 to the current cell and minus to the J plus 1 cell. So when we are iterating, we just accumulate the sum, and in the end, the answer will be balanced and there will be no wrong answer. How to apply for the how to how to change this difference 1D array to 2D difference 2D array. I difference 2D array. I know a blog, but I don't want to see that answer. Let's try to do it by ourselves. Let's assume this from this cell to this cell we need to update every this is the rectangle we are going to form. How to do it? We will add here, we'll subtract here. Okay, when we subtract here, okay, if we don't subtract here, then we can propagate this to the other cells. Okay, we add it here and we have to do it. 10 power 4. Oh no, brute force works, I think. Query per query, we only have 10 to power 4 queries, right? 10 to power 4 into 10 to power 10 to power. This will be 10 to power 8. 25 into 10 to power 8. But this can be clearly, but this this can clearly, but the, we have a good time limit, so we can go for it. But I don't think it will be done in 1 hour and 1 second. After 1 second, it won't be done. Okay, so what should we do? What should we do? If we take update here, we subtract -1 here, but and it to only affect this current this matrix only. I don't want to. If we add here, the every cell is going to update, and then -1. Okay, yeah, -1. So this means, and we don't want to affect these cells also. These cells shouldn't be updated. How to do it? First, I will update this cell to +1, and any out of the bound will be negative -1. Mm, I have like this +1 a -1 and +1 -1. So we can do that. We can have 1 -1 +1 -1. Okay. So this will take around over 10, I think. In our rows. We are iterating over rows and the column, right? Over 10 per query times q queries. Okay, let me write it correct now. Okay, difference array, we are going to treat every row has an individual difference array. So we are going to apply +1 to the every row and -1 to the every end of the end of the column. Okay, this can do it. This okay. I think we can do it by this. It will be open per query, and at the end we okay open q times 10 to the power 4 into 10 to the power 2. It's still 10 to the power 6 into 5. Okay, this is this won't be cleared, notice cleared. In the end, we need to run n square so that to compute the current value of the cell. Yeah, this can do it. Okay. We have an per query we are going to take. So every row and what is the column with? Yeah, this is into the matrix of and rows and columns current map of certain type equal to 0 I less than n for every row, for every column. This is the last step we are going to do. I'm writing the last step. And we need a variable sum. I think we can have this in within the matrix of I comma j plus equal to sum. And we need to update the sum like amount of I comma j. And we have also written math. Okay, now we are going to take the queries. Let me indentate it. We have a proper. Leetcode is not working. This tool, okay, now we have current query in queries. Now current row equal to this is the bond into bond of the row will be the row will be key of 0. Okay, we will start from the key of 0 to row of row is less than equal to key of 0 2 and row plus 1 and mat of row and for the column we are going to add 1 to that corresponding column, that q0 q1 plus plus and mat of row comma q2 q3 to q3 plus 1 and we need to minimize it and and column equal to math dot minimum of n comma control v. we will going to decrease it by 1, and we need to check if this current column is less than n. Minimum, okay. So every time. Mhm. Okay, no. So we can just do this. I think this will give a wrong answer. So Q3 plus n. We have Q3 and Q2 has G. 0 and 2 has common. 1 and 2. And think this will be the column. This is your column. And let's see if this works. Okay, this works fine. I submit it. Okay, we have solved it. I don't think it's completely efficient. Okay, time complexity is Qn n into n, but it's actually Qn. Let's see the prefix to the difference, two-dimensional differences. Updation is off, and how we do this? They should read this full article. Submetric symmetry. State on the rectangle symmetric of a 2D array. That approach would be iterate over each cell within the rectangle for every update and lead to k and into m. Yeah, I talked it about in the brute force. To handle the case, 2D difference array, it's the extension of 1D array design. Okay, instead of updating every cell in the submetric individually, we update just four corners. Okay, 1, 2, 3, 4. If in a helper matrix, we reconstruct the final matrix using prefix sums. Okay, so constant time. Okay, updations queue time. If for row 1 C1, row 2 C2 are the left and right column. Okay, we update this to be what is the update to be, and row 2 and column to the minus p. Okay, okay, let's see how does this work. Okay, if we have this, okay, this is the, let's assume this is row 1, this is row 2, and this is column 1, and this is column 2. So we are going to difference of, we are adding to v to u and subtract the row plus 1 column c1. So we are subtracting minus b, row plus 1 column c1, and okay. So we apply two times, right? I think we should apply two times. Two times prefixum. And row 1 and column n plus 1 minus 1. Okay, okay. C2 plus 1. So we are minus up. We are updating it to minus 2 from there. And we need to again and the prefix with and we need to update here to right row plus we have to put row 1 column row 1. Okay, minus 2 minus we have taken care row 2 plus 1 row 2 plus 1 and column 2 plus 1. The row 2 plus 1 is the row 2 plus 1 column 2 plus. Here we are going to add b plus b. Okay, water vessels R1 C1 plus b R2 plus 1 C1 minus b. Mm-hmm. Okay. Now R1 C2 plus 1 minus b and R2 plus 1 R2 plus 1 C2 plus b. If we don't have if the sides are not in the bonds, what are we gonna do for raw? Okay, take row wise prefixum, take column wise prefixum, as a row wise, column wise, and net update. um, Two traversal only. Only two traversal will lead to the row traversal. For every traversal, we are going to add one plus one plus one plus one. In row wise traversal and column traversal plus one plus one plus one plus one. And whatever there. And then we are going to subtract it. um, Okay, let's try this. Okay, parallel query because we are not column. Sorry, 0, 1, and column 2, 2 and 3. Next we need to the top left cell. That will be matter row 1, column 1 to the 2 plus 31, and this row 2 plus 1 is less than n. Then matter row 2 plus 1, column 1 minus row 1, and other would be row 2 plus 1 less than none, and column 2 plus the amount of row 2 plus 1, column 2 plus 1 plus equal to 1. Now that would be this will be okay. Column 1 we have taken column, we have column 1, okay, row to column 2, and column 2 plus 1 amount of row 1, column 2 plus 1, and I think this is the okay. Top left row column, top right subtracted row plus 1, top right pair row 1, now bottom left row 2 plus 1, and we are multiplying predictions to in row 1, sorry, equal to 1 by 1, row 5 row 0 to column or column equal to j less than plus, and that would be mat of 1 comma j plus equal to mat of previous comma j minus 1. Okay, we have taken this row wise, column wise. Column wise difference. Oh, this is not the correct way. Query column and we have everything. Okay, top left. Okay, meta less equal to one. C1. Okay, C1 is C1. Okay, this row one. Column 2 minus 1. Okay, we did it. And now we have is row 2 plus 1. Yeah, row 2 plus 1, row 2 plus 1 minus 11. We did it. Now we have row 2. Okay, this time now row wise. Oh, okay. This is also no, it's not working, bro. We are updating twice. Why is it so? Like, let's see. Okay, okay. Oh, this was wrong. So this works fine. Proper indentation. That's not working. let's submit. Okay, this has the best time complexity. This is Q plus n into n. Okay, okay. I think I was solving another lit question. Let me see. Videos, no, lit code. This is done. Okay, 1529. 1529. The given is okay. This question was pattern based, I think. Since I solved mine, I roughly solved it. Let's see. You are given a zero index binary string, okay, zero index binary string of length, and you have another binary string s of length n that are initially set all to zero. You want to make s equal to target in one. Okay, target in one operation you can pick an index I is within the range of the indexes and flip all the bits inclusive to the I command mechanism. So we are choosing index and we are flipping all the bits of that suffix of the ith index till the end. Whereas if we choose I, uh, we will flip all the bits till the end. Flip means changing 0 to 1 and 1 to 0. Okay, and minimum operations we need to get. Okay, let's solve it uh, on pen and paper. Okay, uh, our aim is to we have a target uh, binary string from the initially we have all the bits to 0. We need to make it equal to target, and the operation we can perform is choose an ith index and flip all the bits till the end. I to n minus 1, flip it flip it flip it, and that will cost an operation of 1. And the observation is that we are flipping all the suffix indices. If it is 1, we are flipping it to 0. If 0, we'll flip it to 1. And we cannot break the suffix into leaving any sub array in that segment. If let's say an example, if we choose an index, we need to flip all the bits. We cannot choose to flip or not. So this is a crux. Okay, now see that. Let's see the example one. We have example. We first initially we have a binary string of length equal to target 1 2 3 4 5 5 bits. So 0 1 2 3 4 5, and we need to change it to the target. Target is 1 0 1 1 1 0 1 1. Okay, sorry, I'm such a noob. It's 5 and I wrote 6 bits. 1 2 3 4. Okay, since okay, let's compare bit by bit from left to right. Let's compare it. if this is the current string. So in the current string and the target index is opposite, right? It's not, parity is different, so we need to flip it. So we will be flipping all the other I plus one indices, right? If in one operation we will flip it to one. If we flip it the zeroth index, we'll flip it all the way to the end. One, 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 one. And that will pass an operation one. Now this will be our current string. Now we will check again second index. Since we have done the previous values, we have taken care of it. We need to update it, right? Now current is 1, but we actually need a 0, so we will perform a flip operation. So that will change it to 0, 0, 0, 0, way to the end. It will cost another one operation. Okay. Now we have 1. Okay, this is 1, 0. We have 0, 0, 0. This is current. This is the current string, and the third bit we will solve it for the third bit by bit. And we need a 1, so we will need to perform again an operation, suffix operation. We will change it all to the 1, all the suffix of the index. This will cost a 1, and we are the fourth index or fourth bit, we need it to be 1, right? It's 1, we can move forward. It's 1, so we have taken only 3 operations. Let's look at the some test case second. Okay, second case is also 3 operations, right? Okay, now let's look at example second. We have 101. So from 0 comma 0, at current I 0 bit, we need to change it to 1, in one operation we can perform. We perform an operation 1. So all the bits are 0, and we go to the index 1, 1. And since the bit parity, this is the current, this parity is different, we need to perform another operation to change it to the 0, 0, 0, 1. This is the current, and we move to the third index. Since third index and the index parity are different, we need to perform another operation. So this will cost a 1, one operation, and in the end we have the target and the current string equal. So this is the main point. Okay, this problem is kind of simulation, and we will, and what are we going to do? We will have a variable parity uh, denoting the current index value. If it's different from the target index, we will perform an operation, make it to 0, and the parity of all the values will be 0, right? Okay, this sounds good, and I think it's O of 1, we can do it on O of 1. Now we need a variable parity, to be 0, current parity is 0, target length of the string n equal to target length, and operations. How many operations we require? Operation equal to 0. Now current index value will be equal to the parity, right? For int I equal to 0, I is less than n, I plus plus, uh, current, or we can just take out it is either 1 or 0, enter the value of that current bit, target dot caret I minus 0. So this will be the 1 or 0 v. If v not equal to parity, so we need to perform an operation. So pair, okay, operation 1, 1, and parity will be changed to the what we need it, and we need to change the parity, right? Takes or equal to 1, is either 0 or either 1 parity. And okay, we target dot length and it's a method of a string. It's not an attribute or variable. Okay, okay, we get a right answer. Let's see for the custom one. We have 0 0 bunch of 0 and 1 1 1 and 0 1 1 0 1 0 1. So let's see uh, when operation does it take. Okay, it's 8 operation and it's correct. I think I have solved it correctly. Yeah, yep, yep, yep. Hmm. Okay, it's so fun. Let's see how did the first guy did it. Parity mod. Okay. Result will be updated to the current parity difference. If either 1 or 0, we are going to add it. 1 1, okay. This is cool, right? Now operation will be equal to v XOR parity, and parity will be change if the current is changed, right? How to do it, right? Okay, parity, right? Parity XOR. Mm-hmm. Bit, okay, bit is equal to none, right? Okay, parity will equal to b. This one also do it. Okay, this is 100%. Oh, my God. This man has solved a lot of problem, man. Okay, he genuinely solved it. He has a 20% acceptance. He had an he has 840 attempting still attempting and 203 he has done all the problem by himself. No look. Oh God, he's good. He has also solved a lot of problem. 6, 13, and 200. 200 hards are very hard to solve. 213. Let's see if we have another problem to think about it. Okay. Okay, let's end this stream. We have solved good amount of problem. Two mediums till today. One was basically if you know, you know. Other was a very easy question, I think. I really suck at explaining things. Okay, we have a streak of 154 days, I think, and I want to make it 360 days. Let's see how well we do it. Okay, let's redeem something if we have points. We don't have. We are at 299. Then tomorrow we have around 3000 points. It will take a lot of time to get this shit. We have 3 months of no, 4 months of consistency. 4. Okay, let's stop the stream.